4.3.4 Area Applications. Such a question. What applications in real life require using area to determine dimensions of objects or spaces? Skill. I can use the area to find the dimensions of various figures. A rectangular building 12 feet by 18 feet is to be surrounded by a walkway width of X feet. Draw a blueprint to represent this and find the value of X, which makes the walkway have an area equal to the area of the building. So let's recall that the area of a rectangle is length times width. Let's draw a diagram out for this one. So we have our building is 12 feet by 18 feet. And we want to surround it with a walkway. And the width is X feet. It's the width X feet on all the sides. This is X, this is X. This one's also X. I'm going to draw a little more to scale. Alright, so we want to first find the area of the building. It's going to be 18 times 12. That's 216. So that means the area of the walkway needs to also be 216. But before we find the area of the walkway, we need to find the area of the whole thing. So of the building and walkway. So that side length would be, we have X, X, and then we have 12. So that's 2X plus 12. And then this side length would be 2X plus 18. So that's the area of the building and the walkway. We have 2X plus 12 times 2X plus 18. And we can multiply those out. We get 4x squared plus 36x plus 24x plus 216. Combine the like terms. You get this. Now if this is the area of the walkway and the building was 216, if we took 216 away, you would have 4x squared plus 60x for the area of the walkway. Now we want to find when the area of the walkway is the same as the area of the building. So we're going to set those two equal to each other. Notice that all three of these terms are divisible by 4, so we could just divide 4 out of all of these. That'll make it easier to factor it. So over here, let's subtract 54 from each side. So we have x squared plus 15x minus 54 equals 0. Now we can factor it. Draw a box. The first term will go in the first cell, x squared. The constant term will go in the last box, negative 54. We want to split the 15x into two pieces where they add together to give you 15x and they multiply together to give you negative 54. So let's list out the factors of 54. We'll make the smaller number negative since our answer needs to be a positive 15. Negative 54 divided by negative 1, 54. Okay. If we have 2, that is half of 54, that is 27. And then divide by 3, 18. And then 54 divided by 4 doesn't work, it's a decimal. 54 5 doesn't work, that's a decimal. And then we have 9. Okay, let's find those differences. 53, 25, 15, that's the one we want, and then 3 is too small. So we'll use 18 and negative 3. So I'll put plus 18x and then minus 3x. Okay, let's factor out the GCFs out of each row and column. The GCF of these, x, and these ones, negative 3. For these, we'll have x, and then for these ones, positive 18. We want to take the sign of the first term here. So this one's positive, so we put a plus here. This one's negative, we put a negative there. Okay, so now we want to solve these. X plus 18 equals 0, and then x minus 3 equals 0. Well, this one is a negative number. You can't have a negative distance, so that's extraneous. So x has to equal 3 feet. Okay, try the other examples on your own.